Assalamu alaikum. Today the topic of our presentation is 6 LoWPAN and is presented by Malaika and Usman Khan. These are the outline of our presentation and I will discuss few of them and remaining are discussed by Usman. So firstly I will introduce the 6 LoWPAN. It is basically a low power mesh network where every node has its own IPv6 address allowing it to connect directly to internet. This is the architecture of 6 LoWPAN where RFIDs send their packet to FFDs and then send to internet through gateways. RFDs are reduced function devices like constrained or low power sensors and FFDs are full function devices. These are some features of 6 LoWPAN. It supports 64 bits and 16 bits addressing. It is designed for low power, lossy IoT networks. It is used for low power link layer. It supports unicast, multicast and broadcast. It supports for IP routing. It allows direct connection between nodes. It includes a supplementary adaptation layer. I will discuss it later. This is a comparison between protocol stack of TCP/IP and 6 LoWPAN. 6 LoWPAN provides different protocols who support successful communication between nodes. On physical layer, it uses IEEE 802.15.4 physical protocol. This layer is used for conversion of sent packet data bits into physical signal. Data link layer uses IEEE 802.15.4 MAC. The task of this layer is to detect or correct errors which may occur during transmission of data bits. Then the network layer uses 6 LoWPAN over IPv6 which is used for routing and it provides different IPv6 IPs, different addresses to different nodes. Transport layer is responsible for connection oriented or connectionless routing. This layer uses UDP, ICMP because these are less complex and small header size protocols. 6 LoWPAN use application protocol which transmit real-time data. These protocols are COP, MQTT. COP is constrained data application protocol and MQTT is message queuing telemetry transport protocol. COP is preferred over HTTP because it supports the devices in sleep mode. As wireless sensor nodes require to save the battery in sleepy mode, that is why COP is generally used in 6 LoWPAN at application layer. This is the protocol stack of 6 LoWPAN which include a adaptation layer between network layer and data link layer. So what is the need of adaptation layer? Usage of IPv6 in transmission of packet over LoWPAN is not possible due to large header size. Hence, an adaptation layer is proposed by IETF to make IPv6 and 802.15.4 compatible with each other. IETF Internet Engineering Task Force Workgroup. This workgroup plays a significant role to make IPv6 compatible with IP standard IEEE 802.15.4. This layer is placed between network layer and data link layer in 6 LoWPAN protocol network. The main function of adaptation layer is header compression and decompression, fragmentation and reassembly of packet, and routing. This is a packet format of 6 LoWPAN. Here each layer adds their header with payload or real information data packet. Now I invite Usman for further proceeding.
6 LoWPAN security uses AES 128 link layer security, which is defined in IEEE 802.15.4. It provides link authentication and encryption. For more security, transport layer UDP based DTLS protocol is used. For advantages of 6 LoWPAN, there are 3 advantages to 6 LoWPAN system. Firstly, 6 LoWPAN uses open IP standards. This includes many well-known standards such as TCP, UDP, HTTP, and WebSocket that many developers are already familiar with. Another advantage is the lack of an application layer gateway. The only functionality that is needed On the edge router is a bridge between the RF and the Ethernet network. The bridge is incorporated in the 6 LoWPN stack, allowing transport internet integration. Secondly, mesh routing enables network to be more robust with large size because more nodes can talk to one another. The network is self-healing and performance can be optimized for either hop count or link quality. If a transmission path between two nodes is broken. Thirdly, 6 LoWPN support multiple physical layer as well as frequency bands. For the application areas, 6 LoWPN can be any low power wireless node that needs to be connected to the internet. Each node receives an IPv6 address and can be reached in the same manner as any other server on the internet. You can literally ping each node, lighting both residential and commercial. Easily becomes a network with the large nodes of wireless nodes. 6 LoWPN benefits from the large mesh network type routing, allowing increased RF coverage and system robustness. Home automation with internet connectivity and information between devices is gaining momentum in the market. An example of an upcoming home automation using 6 LoWPN is the Tedo smart thermostat. The 6 European solutions, for which the most popular wireless MCU from IT used for 6 LoWPN is the CC2538. It can be used standalone for a 2.4 GHz operation or with the CC1200 for a sub 1 GHz operation for application that requires long range or better sensitivity. There is an option to extend RF range between wireless node with IT's integrated range extenders. The CC2592 is used for 2.4 GHz and CC1190 is used for sub 1 GHz operation. The tools and kits used for 6 LoWPN, there are a number of softwares tools available. The first one is Instant Key. The second one is Kuja Network Simulator, and the third one is Wireshark Packet Sniffer. These softwares are freely available on internet. For the development kits, there are a number of development kits available on eStore. First, you will need to choose your frequency band. There is a 2.4 GHz or a sub 1 gigahertz option. Secondly, depending on your application, whether it's a node or an edge router, you will need to choose the appropriate development tool. Lastly, for range extenders, there is a kit available for either 2.4 GHz or sub 1 GHz. These are the references from which we are conducted our presentation. If you have any questions, let us know in the comment box. Thank you.